Welcome back to the Advanced Microcontroller series. In this session, we are learning about microcontroller interfaces with digital keypad. And here is the agenda: introduction of digital keypad, triggering methods, bouncing effect, circuit on board. Digital keypad provides simple and cheap interface, comes in different shapes and sizes. Preferable if the number of user inputs are less. So if the number of user inputs are more, then which keypad is preferable? Matrix keypad, isn't it? And it is mostly based on the tactile switches. Some common application of tactile keys are HMI, mobile phones, computer mouse, etc. This is the symbol of tactile switches, and this is open switch and this is closed switch. Let me consider one circuit. So here we having one switch here and this end is connected to the ground. So this is ground. So this is switch and this end is connected to the microcontroller. So this is microcontroller, assume. So now this is switch. So during open switch, so this line is floating line, not connected. But during closed switch, it connects to the ground. So this is connects to the ground like this. Now let me consider PDD. So here I am going to consider VDD also. So this is VDD and this is ground. Yeah. So if I close the switch, this one, then current will flow towards the ground, isn't it? So if I close this switch, then current will flow towards the ground. Sorry, this is little big. So current will flow towards ground. So if switch is open, it will flow towards, assume here switch is open. Then how it will flow? It will flow like this, isn't it? So if the switch is closed, the current flow towards VDD to ground. So what will happen here? There may be a chance of short circuit, isn't it? Current is flowing from VDD to ground during closed switch. So there may be a chance of short circuit. So what we need to do? To prevent the short circuit, we need to add resistor. So to prevent the short circuit, we need to add resistor. So here I am adding resistor. So this type of circuit is called pull-up circuit. So this type of circuit is called a pull-up circuit. So when switch is open, it is pulling up. So when switch is open, what will happen? The current will flow like this. So in the pull-up, we having switch state two types. One is open and close. And value of microcontroller pin, whether it is high or low. So during open switch, value of microcontroller pin is 1. But during closed switch, the value of microcontroller pin is low, means 0. So this is what pull up. Okay, let's consider one more example. So now here I am writing, okay, let me erase. So here I am considering one more example. Sorry. So here we having switch. Then so here we need to add one resistor to opposes the flow of current. We need to add one resistor here. So this is ground. So here I am adding one. Here I am adding. So this is connected to the microcontroller. Okay, this is connected to the microcontroller, and this is switch. This is switch, and this is what VDD. So this is the circuit now. This is the circuit. So now when switch is closed, what will happen? When switch is closed, the current will flow like this, isn't it? So now if here microcontroller is accepting this current, so this is the sinking circuit, isn't it? So if this current is greater than the microcontroller current, the problem will happen, isn't it? So what we need to do to prevent this, we need to add load here. So here I am adding one resistor. So we already having one resistor, right? So that is R1, and here this resistor I am naming as R2. So this is R1 and that is R2. Okay, this is R1 and this is R2. So if R1 is less than R2, then so if this resistor value is less than this R2 and here switch is closed, so what will happen? The current flows from VDD to ground. So to prevent this, always R1 should greater than 10 times of R2. Okay, this is the condition. So in the pull down, so this is what pull up. So in the pull down, we having switch state open and closed, and value of microcontroller pin is low during switch is open, and value of microcontroller pin is high when switch is closed. Okay, this is the condition. Okay, next, triggering methods. So here you can see triggering methods. So here which method is there here? So there is two types of methods. One is level triggering and one more is edge triggering. So in this, see in this diagram, so whether it is edge triggering or level triggering, it is edge triggering, but this diagram shows level triggering. So in the edge triggering, so here you can see it flows from high to low, isn't it? So which type is this one? So here signal goes from high to low, and this type of triggering is called falling edge, and this is falling edge, and here you can see signal goes from low to high, isn't it? So this types of triggering is called rising edge. Rising edge. So this is the edge triggering types, and here you can see trigger activates as long as the signal stays high, isn't it? So this is high level triggering. And here in this circuit, so here you can see the trigger activates as long as the signal stays low. So this is low level triggering. So these are the types of triggering. So okay, I'm writing one circuit. So here you can see. So in the previous, I forgot to say, yeah, this is pull down circuit. Okay, here it is pulling down, right? So pull down circuit. And let me consider one pull up circuit. So this is pull up circuit. So this is ground and this is VDD. So here we having switch. So this is connected to the microcontroller pin. So now when switch is open, the signal will be, what will happen when switch is open? Here I am connecting this pin to CRO. So here I am connecting this pin to CRO. So what will happen when switch is open? The signal will be high. So if switch closed, current goes to ground like this. So if the switch is closed, current flows like this, isn't it? And now, okay, let me consider when we press the switch, the current flows like this. So this is falling edge and it stays in the low level. So when switch is pressed, we will detect the falling edge. Okay, high to low. And here you can see the bouncing effect. When switch is pressed, you can see how it will take action. And when switch is released, you can see the action. And this is the contact bounce period. So this happens during switch press or release. So the contact bounce period, so here you can see when we press the switch, what happens? We see multiple rising edges are created, isn't it? So here contact bounce period vary from 20 to 50 millisecond. So we have to adjust in the software. So this is the bouncing effect. So now here you can see, okay, here we having one diagram, right? Let me explain here. So when switch is pressed, okay, so here I am drawing. So this is the, so this is one scenario I am considering. So when switch is pressed, here when we press the switch, falling edge happens, isn't it? It is falling and it stays in the low level. And when you release the switch again, the signal flows from low to high and it stays in high level. So if you press the switch again, then again falling edge and signal stays in low level. So this is the logic. So now how to detect the level? So level detection, how we need to detect level? Okay, let me write the code for level detection now. So when we press the switch, it happens, isn't it? So here I am considering one if condition. If switch is pressed, then here LED should toggle. So LED 1 equals to not LED. So here LED 1. So this should be happen when only press the switch. Okay, when you press the switch, then only it should happen. So this is the logic for level detection. So if this condition is true, means when you press the switch, means condition true, right? Then action will takes place. So how it will takes place? So on off, isn't it? So this means what? On off. So initially it is on, so action takes place. So action true. So here I am writing true. So next it will off, so action not takes place here, so it is false, isn't it? So we having two types of action here. One is true and one more is false. When you press the switch, so let me consider this diagram. Okay, so now here you can see, so you press the switch here. Okay, let me consider open switch. So switch is in released condition. So now what will happen? So this condition is false, so there is no chance of this statement execution, so that is 0. So this condition is false, then there is no action will takes place, so it stays 0 only. But here when you press the switch and action also true, so that is what? 1. You press the switch but action false, so 0 again. True, false, true, false. Same happens here. So same happens. And here again you release the switch, so condition false, that is 0. So this is what? Level detection. And next is the edge triggering. So before going to this, let's write the code and execute using the MPLAB XIDE. So this project I already created, so I am not going to write the code and run the code. So wait, I'll see. So here file, it's stuck. Yeah, here click file, then here we having open project, just click. So this project is already created, so I am not going to do this again. So here home, documents, embedded electronics, so level detection. Just close the previous project, and this is the level detection. So here double click to the source file, we having main.c. See here we considering port D, not port B. Okay, so this is port D, and this switch 1 DDR equals to 1. So here you can see same logic, isn't it? When switch is pressed, LED toggling, and here we considering some delay. And in the main.hc, LED1 DDR is port D, tris D. So tris B means that is port B, tris D means port D. Okay. So see here. Yeah. Now here click build. So build is successful. Now go to the PICSimLab Simulator. So here I am having PICSimLab Simulator. So here click File, Load Hex. So here Documents. So here I am having Production. See here, this is the .hex extension. So now here port D. LED is port D, right? Not port B. So this port B you need to pull down. And now here we having switch tactile keys. So these are the switches. So here I am using this switches. So I am considering this RB0. So now in the code you can see RB0, right? Switch 1 is RB0. Yeah. Now press this switch. Key press, long press. Here you can see LED is toggling. When you press the switch, LED is toggling. And release the switch. It's off, turned off. Again press the switch, LED toggling. Again release the switch. Okay, sorry. Again release the switch, it stopped toggling. Here you can see this is what level detection. This is what level detection. Okay. Next is the edge triggering. Okay. So this is the level triggering. So in case of edge triggering, we having falling edge and rising edge. So for example, power button of your TV. So what will happen when you press power button, long duration, toggle on, toggle off happens, right? So okay, let me consider one circuit here also. So this one. Here we considering two conditions. So here we considered only one condition, isn't it? So here we considered only one condition, but in this condition, so here we having two conditions. When switch is pressed and one more condition, once. So what is once? So initially we considering this one, okay, once equals to 1, and here initially we considered LED 0, means it's turned off. Okay, so now if these both conditions are true, then LED toggles, then once equals to 0. So here you can see switch is pressed. In this condition is switch is pressed, and here once. So when switch is pressed, so this is switch pressed and this is open switch condition. So what will happen? So okay, let me explain again. Okay, so when switch is pressed, it checks if the pin is low, means when you press the switch, falling edge and it is low level, isn't it? So once means smart, it ensures the action happens only one time per press. So initially once equals to 0, and when you press the switch means signal goes from high to low, isn't it? So condition becomes true, switch is pressed, isn't it? And once equals to 1. So here condition is true. So after that what will happen? Switch is pressed and once equals to 0 prevents repeated toggling while holding the button. So if you keep press the switch, then once equals to 0, not equals to 1. So then what will happen here? It is 0. And you release the switch now. Okay. Switch is, that is what? Switch is pressed, but once equals to 0. So condition fails. So here 0. Now you release the switch. Now once equals to 1. Now what will happen here? System resets for next press. So this equals to 1. So this is the logic. So it detects the moment the button is pressed. So it does not continuously react while held. So that's why it is called edge detection. Press event detection. Not the level detection it is. I hope you get the logic. So this is the only difference. Okay. Go to the MPLab XIDE. So here I am clicking open project, then state change detection. So here we having level detection, right? Just right click to the project and click close. Yeah. So now we having, so here you need to click to the source file, then click to the main. So here you can see same thing we considered. So here we having switch is pressed and once. So each time it will see once. Once means I already explained. I hope you get it why once. So it ensures the action happens only one time per press. Okay. Then LED toggles. After that once equals to 0. So else if switch released again once equals to 1. When you release the switch again once equals to 1. Again you press again equals to 1. If you press, what will happen when you press, that is equals to 1. Long press means once equals to 0. Okay, it will check. And main.h. Now click build. So now open PICSimLab Simulator file, load hex. So here state change detection, default production, and this .hex file. So now how it will work? So now press, key press, not toggling, isn't it? Okay, release, again press, off, state change, see here, press it, release, again press, off, press, when you press only, off. So on, release, off. So now key press, no toggling, right? Yeah, that is the logic for state change. So that's all about the microcontroller interfaces with digital keypad. In the next session, we are discussing about tactile key as digital keypad. That's all about the today's session. Thank you all.